Something strange just happened in the sky above us, and scientists are not calling it normal. A pattern that usually behaves one way suddenly flipped, and the readings coming in are unlike anything on record. If you have ever felt like the weather outside your window just does not feel like it used to, stay with me for the next few minutes, because what you are about to hear might explain exactly why, and why this time it really is different. For decades, meteorologists have relied on certain patterns to predict what comes next. Rivers of air moving high above our heads, invisible currents in the ocean, pressure systems that rise and fall like breathing lungs. These patterns were never perfectly predictable, but they followed rules. They had rhythms. Scientists could look at decades of data and say, with reasonable confidence, this is roughly what should happen next season. That confidence is now being tested in a way nobody expected. The pattern in question involves the movement of air high above the planet, a current that circles near the top of the atmosphere and normally stays fairly stable through the year. This current acts like a fence, keeping extremely cold air locked away in the polar regions, while warmer air stays where it belongs closer to the middle of the planet. When that fence weakens or bends out of shape, the cold air does not stay put anymore. It spills out, sometimes thousands of miles from where it should be. Recently, instruments monitoring this current recorded a shift that surprised even experienced researchers. Instead of the usual gentle wobble, the pattern buckled sharply, almost like a rope being yanked from one end. Cold air that should have stayed locked near the pole began pushing outward in a shape scientists had not documented with this kind of intensity before. It is the kind of anomaly that makes veteran forecasters pause and double-check their own equipment. Now, you might be thinking, weather changes all the time, so what makes this particular shift worth talking about? Fair question. The difference lies in the speed and the depth of the change. Normally, these shifts unfold gradually over days or weeks, giving forecasters time to adjust their models and warn the public well in advance. This time, the shift happened fast, and it happened at a depth in the atmosphere that usually stays far more stable than the surface weather we experience daily. Here on Universe Proof, we always try to connect what happens on Earth to the bigger picture beyond our planet, and this story is no exception. Some researchers believe that unusual solar activity, changes in the amount of energy the sun sends toward Earth, may be playing a quiet role in destabilizing these atmospheric currents. It is not the only explanation on the table, but it is one that connects our daily weather to forces happening 93 million miles away. To understand why this matters, picture the atmosphere as a giant spinning top. When it spins evenly, everything above and below stays balanced, predictable, and calm. But introduce a wobble, even a small one, and the whole system starts to shift in ways that ripple outward. A wobble at the top of our atmosphere does not just stay at the top. It works its way down, influencing storm tracks, temperature swings, and even how moisture moves across entire continents. Scientists tracking this event describe watching data streams that looked almost like a heartbeat monitor spiking unexpectedly. One moment the readings were within normal range, and the next, they jumped in a way that triggered internal alerts at more than one research center. Multiple independent teams, working with separate instruments in different parts of the world, reportedly picked up similar signals around the same time, which is part of why this event is being taken so seriously. What makes this truly different from past anomalies is not just the strength of the signal, but the fact that it appears to be lingering. In previous decades, similar disruptions tended to snap back into place within a matter of days. This time, early observations suggest the pattern is holding its unusual shape for longer than expected, refusing to settle back into the rhythm scientists are used to seeing. A short-lived wobble is easy to dismiss. A stubborn one is much harder to ignore. If this pattern continues to behave unpredictably, the downstream effects could reach further than most people realize. Regions that rarely see extreme cold could experience unexpected freezes. Areas used to mild, steady seasons could see sudden swings between extremes. Farmers, shipping routes, energy grids, and everyday commutes are all quietly connected to these large-scale atmospheric behaviors, even if we rarely think about the sky above us in those terms. It is worth pausing here to say this clearly, because we never want to create panic without context. Weather systems are complex, and even unusual signals do not automatically mean disaster is coming. Scientists study these patterns precisely because understanding them helps us prepare rather than react in fear. What is happening right now is best described as a warning sign worth watching closely, not a guaranteed catastrophe. The goal of paying attention is preparation, not panic. Still, the reason this story keeps circulating among researchers is because of how many boxes it checks that usually only appear during major climate shifts. Unusual speed, unusual depth, unusual persistence, and signals appearing across multiple independent monitoring systems at once. Individually, any one of these might be brushed aside as noise. Together, they form a pattern that is much harder to explain away as coincidence, which is exactly why so many scientists are choosing to speak up now rather than stay quiet. There's also a historical angle worth mentioning. Every so often, throughout recorded climate history, similar disruptions have appeared before major shifts in seasonal behavior. Not every disruption led to something dramatic, but almost every dramatic shift was preceded by a disruption that looked a lot like this one. That correlation is not proof of what happens next, but it is exactly the kind of pattern that keeps atmospheric scientists studying the data late into the night instead of dismissing it. One of the more fascinating parts of this story is how interconnected our planet's systems really are. A shift high in the atmosphere can influence ocean currents. Ocean currents can influence rainfall thousands of miles away. Rainfall patterns can influence crop yields, which ripple into economies, which ripple into everyday life for people who never once thought about the invisible currents spinning far above their heads. Nothing in the system exists in isolation, and that is part of what makes it endlessly worth studying. Researchers are now using satellite data, weather balloons, and ground-based sensors together to build a clearer picture of exactly how far this disruption might spread. It is a bit like assembling a giant puzzle where new pieces keep arriving every single day. Some pieces confirm what scientists suspected. Others raise brand new questions nobody had thought to ask before this event began unfolding. That uncertainty, frustrating as it may be for forecasters, is also what makes this moment scientifically exciting. If you are watching this because you noticed unusual weather where you live, you are not imagining things, and you are definitely not alone. Across different regions, people have been reporting temperature swings and storm behavior that feels off compared to what they remember from previous years. Anecdotes are not scientific proof on their own, but when they line up with what instruments are recording at the same time, it adds another layer of confidence that something genuinely unusual is happening around us. Here on Universe Proof, our mission has always been to take complex science and turn it into something everyone can actually understand, without the jargon and without the fear-mongering that so much of the internet leans on for clicks. We want you walking away from this video informed, curious, and a little more aware of how connected our planet truly is, from the ocean floor all the way up to the edge of space, where the sun's energy first reaches us. So where does this leave us right now, today, as this pattern continues to be monitored around the clock? Scientists are watching closely, models are being updated in real time, and new data is arriving faster than most research teams can fully analyze it. What we do know is that ignoring early signals has never been the smart move throughout history. Paying attention now, staying informed, and understanding the science gives all of us a better chance to adapt to whatever comes next. It is easy to feel small when talking about forces this massive. Currents spanning thousands of miles, energy traveling from the sun, systems that took decades to understand even partially. But understanding does not require controlling. It simply requires curiosity, the same curiosity that brought you to this video in the first place. The more people understand how these systems work, the better prepared entire communities become when unusual patterns like this one start showing up on the radar. There is another piece of this puzzle that rarely gets attention outside research circles, and it involves the ocean rather than the sky. Beneath the surface, slow-moving currents carry warm and cold water across entire ocean basins, acting almost like a conveyor belt that regulates temperature for huge portions of the planet. When atmospheric patterns above the ocean shift unexpectedly, the conveyor belt can be nudged out of its usual rhythm too, and changes at that scale do not correct themselves overnight. They can take months or even years to fully settle. This is part of why scientists are being cautious rather than dismissive about what is happening right now. A short-term wobble in the atmosphere is one thing, but if it starts influencing ocean behavior even slightly, the consequences could stretch far beyond a single unusual season. Think of it less like a single loud event, and more like the first domino in a much longer chain, one that researchers want to understand before more pieces start moving. It also helps to remember that our planet has been through disruptions like this before, long before satellites or supercomputers existed to track them. Ice cores, tree rings, and ancient sediment layers all preserve evidence of past climate wobbles, some subtle and some dramatic. Reading that ancient evidence alongside modern satellite data gives scientists a rare kind of perspective, comparing what is happening today against a timeline that stretches back thousands of years rather than just the last few decades. What is different now, compared to those ancient records, is the sheer amount of real-time data available to researchers. We are no longer waiting years to piece together what happened after the fact. Instruments are capturing this event as it unfolds, hour by hour, which means scientists have a genuine opportunity to understand cause and effect, while the pattern is still active. That real-time visibility is exactly why this story is spreading through research communities so quickly right now, because patterns like this rarely stay quiet for long. If new data confirms what early signals are suggesting, this could end up being one of the more talked about atmospheric events in recent memory, and you will have understood the full picture before most people even hear the headline version. That is exactly the kind of advantage curiosity gives you in a world full of noise and half-explained news. Before you go, if this video helped you understand something you have been noticing in your own sky lately, drop a comment and tell us what the weather has felt like where you live. We read every single comment, And honestly, some of the best story ideas on this channel come directly from viewers describing what they are experiencing in real time. Your observations genuinely help shape what we dig into next, so do not hesitate to share what you have seen. If you found this breakdown useful, share it with someone who has been asking why the weather feels different lately, because chances are they have noticed it too and just did not have the full explanation. A share from you helps this channel keep producing deeply researched videos like this one, free from clickbait and full of context instead of fear. It genuinely makes a difference, and we notice every single time it happens. Make sure you are subscribed here on Universe Proof, because we are going to keep tracking this pattern as it develops, along with the countless other mysteries connecting our planet to the wider universe around it. Turn on notifications so you do not miss the next update, especially if this story continues to unfold the way early signals are suggesting it might. Thank you for spending this time with us today. Stay curious, keep watching the sky, and we will see you in the next one.